Welcome to Conditional Probability Review. All right, so in this lesson we're going to look at how to determine independent and dependent events from the conditional probability formula. And then we're going to do some conditional probability problems with a Venn diagram that we're going to put together. All right, so you have the top part in your notes. Two events are called independent if the occurrence of one event does not affect the probability of the occurrence of the other event. Two events A and B are independent if the probability of B given A is equal to the probability of B, or the probability of A given B is equal to the probability of B. In other words, if the probability of B from the conditional probability formula is equal to just the probability of B itself, calculated all on its own, then A and B are independent. I'd like you to put in your notes, I put the second example in your notes and I didn't put the first example. And so you don't have to put in the green box there, but the rest if you could. So if the probability of B given A is equal to the probability of B and A divided by the probability of A, which is the conditional probability formula, if that's equal to the probability of B, then A and B are independent events. So let's take two events. All right, heads, A is heads, and the probability of heads, there's one head out of two sides to the coin, so the probability would be 1/2. There's one tail, so if B is tails, the probability would be 1/2. All right, so we're going to use the conditional probability formula to determine whether or not these are independent events. All right, so we're finding the probability of B given A, which is the probability of tails given heads. And so what's the probability we'll get tails on the second flip, given that we got heads on the first flip? All right, so we need the probability of heads and tails, and I'll just put it over here. Probability of heads and tails, that would be 1/2 times 1/2, or 1/4. So we're going to take that 1/4 and then divide it by the probability. Actually, maybe I'll write that out. So here we're calculating the probability of heads and tails divided by the probability of the given, which is heads. But we already have what the probability of heads and tails is. That's 1/4. And we'll divide that by the probability of heads, which is 1/2. If you divide a fraction, when you're dividing fractions, you multiply by the reciprocal. So this would be the same as 1/4 times 2/1. And that would be 2/4 or 1/2. So notice we get the same thing. So since the probability of tails given heads equals the probability of just tails all by itself, these are independent events. I have an example of some dependent events in the example of dependent events in the next example. I have it all written into your notes already. So because I have it all written into your notes, there's no point in me having you write it, me erasing it and writing it. I'll just go over it with you. And actually, as I look in your notes, just in case you didn't notice, the very top part was in your notes. So the part that's not, it wasn't in your notes, is just the bottom part. So if you want to just kind of summarize that, put that into the side somewhere. That way you'll have an example of here are two. We know these are independent events because the probability of one given the other is just the probability of that first event all by its lonesome. But here we have some dependent events. All right, so, and I believe I put this entire thing in your notes. Oh, I'm sorry. I did not put any of this in your notes. I looked at one in your notes. I didn't put any of this one in your notes. So I don't have that first part. when I was glancing, I was looking over at the dependent events. That's the one in your notes. So if you could put this part in your notes, that would be awesome. Let's take a look at this one. So this one is completely in your notes. If the probability of B given A, so that would be the probability of B and A divided by the probability of A. If that is not the same as the probability of B, then A and B are dependent events. So here A is going to be green marble and B is going to be blue marble. And just so you know where I'm reading, this is my famous arrow that points out where I'm reading. And it doesn't want to move. Come on. There, I'm reading right there. There are 10 marbles. 3 are green and 7 are blue. So the probability of getting a green marble is 3/10. I'm going to just take this away. Oh, we got rid of half the words. So the probability of the green marble is 3/10. There are 10 marbles altogether. 3 of them are green. The probability of the blue marble is 7/10. Right? So now we want to find, first of all, right, to use the conditional probability formula, we need to find the probability of A and B. All right. So probability of A and B. This would be without replacement. So the probability of A is 3/10. There are 3 green marbles, right? And there are 10 marbles altogether. Once I take out a green marble, that marble's gone. Then there are only 9 marbles. There are still 7 blue marbles, but there are only 9 marbles altogether. Right? So we have 3/10 times 7/9. We could reduce the 3's right here, right? So 3 divided by 3 is 1. And 9 divided by 3 is 3. And now we multiply across. 1 times 7 is 7. 10 times 3 is 30. So the probability of A and B, no replacement, would be 7/30. All right, so now we're using, there we go, the conditional probability formula, which is the probability of B given A. So B is the blue marble. So this is the probability of getting the blue marble given that we got the green marble already. So we would take the probability of green and blue divided by the probability of green. The probability of green and blue, we just found it over here, is 7/30. The probability of the green marble is 3/10. So 7/30 divided by 3/10 is the same as 7/30 times 10/3. Be a nice idea to reduce here, right? Those are both divisible by 10. 10 divided by 10 is 1, and 30 divided by 10 is 3. And then we multiply across. So 7 times 1 is 7. 3 times 3 is 9. So notice that we got a probability of 7/9, right? Is that the same as the probability for blue? Well, no. The probability for blue is 7/10, not 7/9. Get rid of my arrow here. So, since 7/9 does not equal 7/10, therefore A and B are dependent events when I pick without replacing. Right? So, picking a marble without replacing, that is a dependent event. We know A, first of all, we change the sample, so it has to be a dependent event. But now we can also calculate it out algebraically that this has to be a dependent event because the probability of picking the blue marble after we picked the green marble is not the same as the probability of just picking a blue marble. Okay? So here's how you can determine mathematically whether 2 events are independent or dependent. And like I said, this whole set of notes, the second problem was in your notes. Right? So I was very kind. I put the second one in there. Oops, forgot the first. All right, so this one we're going to do together. And it is a lot easier with a Venn diagram. I drew the Venn diagram for you. It just is not in color. One morning, there were 82 customers for breakfast at Sam I Am. My screen thing is blocking. There we go. 35 customers ate green eggs, 32 ate ham, and 20 sat in a booth. There were 12 who ate green eggs and ham, 8 who ate ham in a booth, 6 who ate green eggs in a booth, and 2 who ate green eggs and ham in a booth. This is the truth. Create a Venn diagram of this situation and fill in all parts with the correct number of customers. All right, so first of all, I have 3 circles there. One of them, there are 3 conditions, right? There's sitting in a booth, there's eating green eggs, and there's eating ham. Let's make the circle that's green for me, let's make that the green eggs. So this is you ate green eggs. We'll make the red one, you ate ham. What? I put hat. Don't eat hats. You ate ham. Oops. This is going to be that kind of recording, is it? And then the purple one will be you sat in a booth. All right, now when you're doing a Venn diagram, start at the innermost place. That means we need to start right here. That is the innermost place. I'm actually going to write in a different color than any of these. I'm going to write in blue. Right? This is the innermost spot. This is the spot for the people who ate green eggs and ham and sat in a booth. All right, let's see if we can find that. So now if we're looking at the numbers here, do you see? Green eggs and ham in a booth. Those are the people, those 2 did everything. They go here. Now when you're calculating out all the rest of them, do not include those. So remember to include those 2 in every other circle. Right? So they're in the green circle, they're in the red circle, they're in the purple circle. They're already there. All right? So we've already got 2 people accounted for. We need to make sure that we take them out. Let me make that a little bit neater. We don't count them twice, right? We gotta make sure we take them out of the other counts. Those 2 people are already accounted for. All right, so now we want to work, so that was the innermost. That was the place where the 3 overlap. After the 3, you want to do where the 2 overlap. And we have 3 places. We have where the red and green overlap, the purple and green overlap, and the purple and red. It does not matter which ones you start with. Let's just figure out one of them first. There were 12 who ate green eggs and ham. All right, let's start with that one. All right, so 12 ate green eggs and ham. That includes the 2 that also sat in a booth. All right, so we won't include those 2 over here. This is just going to be 10. Together, it's 12. 2 of them also sat in a booth, and 10 of them didn't. But all 12 of them ate green eggs and ham. All right, so we got that one covered. All right, so now we want to find ham in a booth and eggs in a booth. Well, first, the next one up is ham in a booth. I see 8 who ate ham in a booth. All right, so those 8 are in the section for ham and booth. So that is the red and the purple, where the red and purple overlap. But hey, 2 of them are already there, right? Because this is where the red and purple overlap, right? This, and this. Right, that's where the red and purple overlap. So 2 of them are already there, right? So we want to take those 2 out. We want 8 all together. So this is going to be 6. That gives us our 8 all together. And then finally, we have the last group, the 6 who ate green eggs in a booth. And we want to, that includes all of these people, and then all of these people, right? So it's that section there. We already have 2 accounted for. Those are the 2 that also ate the green eggs, so we're going to take those out of what we're going to put in the next section because they're already there. They're already counted for. So we've got 6 who ate green eggs in a booth, 2 of them also ate ham, and 4 of them didn't eat ham. All right, now we've got all the center sections filled in. Now we fill in the sections for just green eggs, just ham, just booth. Now, if you ate green eggs and you ate ham, you still ate green eggs. If you ate green eggs and ham and sat in a booth, you still ate green eggs. And if you ate green eggs and sat in a booth, you still ate green eggs. So we already have 16 people accounted for, right? We got 16 people that ate green eggs already accounted for. So the number that's going to go in this section, there were how many people? There were 35 customers who ate green eggs. So in this section for green eggs is the 35 who ate green eggs minus the 16 that are already down here also eating ham and sitting in booths. So that means that we have 19 in the green egg section, okay? And you don't have to, always write the number we're subtracting. I'm going to put that way up here. But maybe for the notes this time, let's do it just so it's clear where this number came from. It's the 35 total people who ate green eggs. Green ham, I don't even know what that is. I think that's moldy ham. The 35 that ate green eggs, 16 of them did something else, and 19 of them just ate green eggs. Right? So now we've got all 35 covered. All right, so now who's next? 32 ate ham. All right, so there's 32 total people eating ham, but we've already got 18 that are eating green eggs and sitting in booths along with eating the ham. So we're going to take those 18 out. So that's going to be 14 people just ate ham. And then we have 20 sitting in a booth. Some of them have eaten green eggs and ham for some reason. All right, so there's 20 who sat in a booth minus the 12 who were doing other things. All right, so 20 minus 12, let's move this over here. That means 8 just sat in the booth and they didn't eat the green eggs and ham. Maybe they had pancakes or something. Okay. Now we need to make sure that we have accounted for everybody because it says there were 82, well, what a great underlining, but there were 82 customers. All right? So we have to make sure that everybody, oops, I put the eraser in the wrong spot. Here, we'll do that, and then we'll just move. No, I guess we can't. Can I just move the line up? No, of course not. That would just be too easy. Okay, we'll just erase it and just forget about underlining. But we need to make sure we've got 82 people there. So I'm going to get my calculator out, and I'm going to add up all the people that we have represented. All right, so I'm going to add up all the spaces. We got a 14, we got a 10, we got a 2, we got a 6, we got an 8, we got a 4, and a 19. 1, 2, 3, 4, 5, 6, I should have 7 numbers. 1, 2, 3, 4, 5, 6, 7 numbers. When I add them up, I get 63, not 82. 19 people are missing. Where do those people go? Well, those people go out here. They were at Sam I Am's for breakfast, but they did not sit in a booth, they did not eat green eggs, and they did not eat ham. Maybe they had pancakes and fruit at a table, right? They were not part of the green eggs and ham sitting in booth group, right? So those were the rest of the people. Now we've got everybody accounted for, and now we can find the 3 probabilities here, or 3 probabilities. Because A was make the Venn diagram. So B is find the probability that a customer sat in a booth given they ate ham. So this is B, the probability of Booth given ham, which is equal to the probability of Booth and ham divided by the probability of ham. So Booth and ham, that's the overlap between Booth and ham. So that includes the 2 people that also ate the green eggs, plus the 6 people that just who didn't eat the green eggs, but sat in the booth and eating ham. All right? So it's the overlap between the red circle and the purple circle. So there are 8. Oops, sorry. There are 8 out of 82. Don't forget that. Right? So there are 82 total people. 8 of them ate ham in a booth. And then divide that by the probability of ham. Right? So that includes everybody who's in the red circle. So 14 plus 10 plus 2 plus 6. So that's going to be 32 out of the 82 people. So that would be 8 over 82. And then you multiply, to divide fractions, you multiply by the reciprocal, times 82 over 32. Notice that you could cancel out the 82s. You can also reduce the 8 and the 32. Right? Those are both divisible by 8. 8 divided by 8 is 1. 32 divided by 8 is 4. So you have a 1/4 probability of sitting in a booth given you ate ham. So 1/4 of the people who ate ham sat in a booth. Let's find the next one, C. What is the probability that a customer ate ham given the 8 green eggs? So we want the probability of ham given green eggs. So that would be the probability of ham, right? So we just found that, right? That's the 32, excuse me. Gotta do the probability of ham and green eggs. Just got distracted for a second. My phone is ringing. Divided by the probability of the green eggs. I'm just going to put green. Maybe if I can I move it over? No. So probability of green it is. You know what I'm talking about. So the probability of ham and green eggs, because this is the probability of ham given green eggs. Right? So whenever we have the conditional probability, we take the probability of both divided by the probability of the given. So the probability of ham and green eggs is the overlap between the red and green circles. So that would be the 10 and the 2. So that would be 12 out of 82 divided by the probability of green. So there are 35 in the green, right? Think about that, we can remember that there were 35 people who ate green eggs. So if we add the 19, the 10, the 2, the 4, we get, of course, 35. And let's see if I can just squeeze that in there. Just need to squeeze in the 35 over 82. Well, that's the same as 12 over 82 times 82 over 35. The 82s cancel. 12 and 35 have nothing in common because 35 is 7 times 5, and neither of those are factors of 12. So our final answer is 12 over 35. All right? So a little better than 1/3 chance that you ate ham given you ate the green eggs. If you're gonna, what's green eggs without ham, I guess. And then finally, let's do the last one, which is what's the probability that a customer ordered green eggs and ham given they sat in a booth. All right? So this one, we've never had a conditional probability like this one. So this is the probability of ham and eggs given Booth. And I'm going to have to write over my Venn diagram. I'm going to make sure I don't write on the words though. So that would be the probability of ham and eggs and Booth divided by the probability of Booth. Oops, that's supposed to be a P. Well, we know what the probability of ham and eggs and Booth is, right? That is the probability that was way in the center there. The two people that did everything. So that would equal 2 out of 82 divided by, so the probability of Booth is there were 20 people, right, who sat in a booth out of the 82 people. This is the same as 2 over 82 times 82 over 20. We can cancel the two 82s, and 2 and 20 are both divisible by 2, so 2 divided by 2 is 1. 20 divided by 2 is 10. So you have a 1/10 probability that you would eat green eggs and ham given you sat in a booth. I think I would be one of the table people because I ain't eating green eggs and ham. No, sir. No, Sam, I am not. All right. So I think this is the last slide this is actually the last slide for probability. This was it. We ended with Sam, I am, and green eggs and ham. And I think this is the last slide. I'm going to double check. But I tell you, I would not eat them in the rain, and I would not eat them in the train, and I would not eat them at the Fox, and I would not eat them in a box. And I would not eat them here, and I would not eat them there. I would not eat green eggs and ham anywhere. I will not eat green eggs and ham. I will not eat them, Sam, I am. So thanks for watching. Bye for now.